All right, so in our previous examples, we assumed that the rate of change of income was given by the continuous function f. Now, this assumption is reasonable because income from a vending machine is often collected daily. Now, in such situations, we assume that the income is received in a continuous stream. That is, we assume the rate at which income is received in a continuous function of time. So the rate of change is called the rate of flow of the continuous income stream. So the total income for a continuous income stream, if our function is the rate of flow of a continuous income stream, then the total income produced during the period from t equals a to t equals b, from here to here. So whatever our stream is, whatever our function is just going to be the integral from a to b of our f of t dt. So we just have to do that integration and we can get our total income. Now, what about a future value of a continuous income stream? Now, remember, a continuous compound interest formula is A equals PERT, PE to the RT, where P is the principal or the present value, A is the amount or the future value, R is our annual rate of continuous compounding interest expressed as a decimal, and T is the time in years. Then the principal is invested. So, for example, if we're earning 8% compounded continuously, then the future value of $2,000 invested for 9 years is, well, 2,000 e to the 0.08 times 9, or $4,108.87. So we go back to the trust paying $2,000 per year that your aunt's going to give you. And then the total value of the trust after 10 years is $20,000. And that's equal to the area under the graph of f of t equals 2,000 from 0 to 10. Now, if at the end of each year you invest the $2,000 you earned at 8% compounded continuously, the amount at the end of 10 years to the nearest dollar would be what? Well, you're going to have 2,000 e to the 0.8 times 9 plus 2,000, then 8, and then 7, and so on. And then it's going to add all those together, and you're going to end up with 29,429. Again, you're going to have to sum all 10 of those together to get that value. Now, this amount actually underestimates the future value of the continuous income stream because deposits are made only once per year. They're not continuous. Now, the future value of the continuous income stream is equal to the area under the graph of 2,000 e to the 0.08 times 10 minus t, where, that's going to be from 0 to 10, depending on what year it is. So we're going to integrate for the future value from 0 to 10 of 2,000 e to the 0.08, that's your interest, times whatever point of time it is, 10 minus t dt. And so we plug all that in and we end up with 30,639. So that's how much you'll receive, including the interest. So how much is your interest? Well, since you received 20,000 in income from the trust, the interest is the difference between this value and 20,000, which gives you $10,639 in interest earned by the income received from the trust over the 10-year period. Now, for that continuous income stream of the trust, the rate of flow of the function was just our f of t is equal to 2,000 because that was our constant function and continuous function. Now, the definition of the future value of a continuous income stream for some arbitrary rate of flow is going to be given as this here. So if f of t is the rate of flow of a continuous income stream from 0 to capital T, and that's the end of t years, whatever that is. And if the income is continuously invested at a rate of r, again as a decimal, compounded continuously, then the future value at the end of t years is given by, well, future value equals 0 to t of your original function times e to the little r times capital T minus t dt. Now, if we remember, r is just a number. Capital T is just a number. So we can pull those out and say, okay, well, that's going to be pulled out, and we'll have what's left over then is e to the r times negative t. And so this part stays in. So we're pulling out the constant. We're keeping the part that has the variable in it here. This part will have a variable in it. And so this is going to be what we actually have to do the integration of to find our future value of the continuous income stream. Okay, so that's going to be kind of the key equation that we'll need to do to be able to solve this. So what do we have here? Well, we're going to do the same example 4, but we're going to use the interest rate of 9% compounded continuously. So future value then is going to be what? Well, it's going to be e to the 0.09 times how many years? It was 5 years. And then we're going to have from 0 to 5. And now our f of t is 5,000 e to the 0.04 t. And then remember, we're taking e to the negative r. In this case, r was 9. So -0.09 times t. That looks not like a 9, but now it does. And then dt. All right, so what can we do? Well, looks like when you multiply those two together, they both got some t's in them, so we can add the powers, and we can also pull that 5,000 out in front. So we can have 5,000 e to the, well, that's going to be 0.45, 0 to 5. Now, if we have 0.09 minus, and we add 4 to that, that's going to be e to the minus 0.05t, and then dt. Now that's into a thing where we can say, well, let's let u equal negative 0.05t, du equals a negative 0.05 du. And so now we have to multiply this by a negative 0.05. And so we have to divide this by a negative 0.05. So now we have 5,000 e to the 0.45 divided by a negative 0.05. And now we have the integral of, and that's going to be now e to the u du. Okay. Well, we know the integration of that, it's going to be just e to the u. So now we have 5,000 e to the 0.45 over negative 0.05 times, now we have e to the negative 0.05 times 5, because we evaluate it. We're going to, I'm just kind of, well, maybe we shouldn't jump ahead. Maybe we should go ahead and do it as we should here. Let's just do it in stages. All right, so then it's going to be e to the negative 0.05 t from 0 to 5. And that, what I was doing is I was already plugging in the 5, and I was going to plug in 0. But we'll keep it in steps for now. E to the 0.45 over negative 0.05, e to the negative 0.05 times 5 minus, and then we have e to the minus 0.05 times, and then we have a 0. All right. And so now it looks like I better start typing that into my calculator. So we have 5,000 e to the 0.45, and then divided by negative 0.05 times, and then we have e to the negative 0.05 times 5, and then minus, and then we have e to the 0, which is 1. And so that gives us a value of, where's my writing? So that's going to be 34690.5427. But do we want, okay, we want it to the nearest dollar. And so that's going to be 3469, and that'll be a 1. Okay. So that's going to be kind of the uh, total, well, wait. That's going to be the future value. Okay. And then they also want the interest. And so we have to calculate interest now. So with interest, here's our formula. And so what we're just going to do is we're just going to take the integral from 0 to 5 of 5,000 e to the 0.04 t dt. And so we are going to have what, 5,000 over 0.04, and then it's going to be e to the 0.04 t evaluated from 0 to 5. So 5,000 divided by 0.04 is going to give us 125,000 again. So we'll have 125,000 e to the 0.04 times 5 minus e to the 0.04 times 0. And so if we multiply all that times, we get e to the 0.05 times 5 minus 1. And we get, all right, so that gives us 27675. So that's going to be basically how much it gets us with all the interest straight from here. Now, if we take this number off of this number, our interest is going to be 34,691 minus 27,675, and that gives us 7,016. So that's how much interest we gained for that whole process. So that's going to be our future value. we had to find, what the compounding interest, and then we found the difference, and that's going to be our how much we made with interest. All right, so let's stop there. We'll come back for some more.